Good morning, all of you. Today is another wonderful day. We are going to start with a very interesting and very, what to say, one of the most lovely subjects in your life. We'll be dealing with the second module of analog and digital communication. We'll see what are the things that we are going to study in this module. According to the syllabus, we begin our study with the review of random variables and random process. This is your syllabus. We have already studied basics of probability in our engineering mathematics, and we'll be having a small review of what a random variable is and what is a random process in this module. We'll study what are continuous and discrete variables, statistical averages, entropy and differential entropy. What do you understand by entropy? Level of uncertainty. All these things we are going to deal with is about uncertainties. Differential entropy of a Gaussian random variable. I hope you remember what is a Gaussian distribution. Probability distributions you might have studied. What is Gaussian random variable? We will see in detail about Gaussian random variables. We'll study conditional entropy, mutual information, and most importantly, what is called a stochastic process. What are the conditions for a stationary random variable? What is WSS, wide sense stationary? We'll study what is the autocorrelation function and how to find out the power spectral density. We'll take a linear time invariant system LTI as an example, and we'll study in depth about how this performs. So this is your syllabus. This is what we are going to deal with in the second module. So we'll begin with review of random variables and random processes. In the previous semester, while studying Python programming and scientific computing, I believe that I've given you an introduction on how to generate random numbers. What is meant by a random number? What do you mean by a random variable or a random process? We have already studied this in our engineering mathematics when we were studying about probability and so on. And most of our things what we'll be dealing with is a practical application of the engineering mathematics what you have already studied. Okay. We'll be going through, but don't worry. We'll be going through from the scratch. Presuming that you do not have any other knowledge, I will start from the basics. I'll keep going on. But if there are situations where you don't understand things, you can always stop me and ask me. Okay. So an signal could be either deterministic or random. So deterministic means you're capable of determining what could be the future of a signal because you're deriving a mathematical equation. You're putting an equation x of t in such a way that the value of t changes, x changes accordingly. Okay, in a situation where the time changes, the output or the voltage or whatever is the variable you want to assess changes accordingly, and we have an equation in such a way that we are capable of understanding what would happen in the next few moments. We call it as a deterministic signal. Obviously, the next part is called as random signals. Random signals are those that you cannot predict. There are regular changes. For example, I am speaking continuously. All of a sudden, I am stopping. Again, I am speaking continuously. So, you cannot really predict how a random variable works. I am converting my voice signals into a mathematical equation and I make a random variable. But random variables are some things that you cannot really predict what is going to happen in the coming few moments. All what we are going to study now is about random variables and the random processes. So as we get into some basics of probability, some things that you might have already learned. First thing is a random experiment. What is a random experiment? A random experiment is something whose outcome is unknown or something that you cannot predict. A random experiment, then you have a random event. A random event is an outcome or a set of outcomes of a random experiment. Set of all possible outcomes is called as sample space. There might be situations in your exams where you are asked the direct definitions. And if you are unable to write it, you won't get marks. So everything, whatever we are discussing here is important. So let us consider this to be a sample space. These are the all outcomes, all possible outcomes, and this is the outcomes of a particular event. We have an event that is expected to occur. We have a set of all possible outcomes, what we call it as a sample space. Okay, we have all the outcomes here. We have an event that has occurred, and this is the outcome of all the occurred events. Suppose that there is a random experiment that is repeated n number of times. If an event A occurs na times, then the probability P of A is defined as the limit of relative frequency Na by n of the occurrence of A. So here we are defining the probability of a random experiment. Let us consider an event A, and this event A has occurred Na times. In that case, the probability of A to occur will be limit n tends to infinity Na by n. N is the total number of times that the experiment has been done. Let us assume that The random experiment, what we are going to do is just throwing a dice. Let us assume that the event A is, we are getting 2. Okay. You are repeating this 5 times. You are throwing a dice 5 times. And here we are defining A to be an event where 2 falls. Okay. Now, the probability that 2 can fall will be 2 times it has fallen means 2 by 5. Okay. Are you all able to understand? That is, the probability of an event that has occurred when n times it is repeated will be Na by n with limit n tends to infinity. Is that clear? So the probability A of an event is found without experimentation. So what we are doing is that with the set of history of our experiments, we are capable of predicting, or we are assuming the probability that an event A could be occur. To what extent the possibilities that A could occur. This is done by the total number, by counting the total number of n possible outcomes of an experiment. So when I'm throwing the dice for 5 times, the n will be, maximum will be 5, right? The maximum number of times I can get 2 will be 5. Am I right? Because I'm throwing dice only for 5 times. Okay. If Na of these outcomes belong to event A, that means if 2 or 3 or 4 or whatever is the number of times that 2 has fallen is n of A, then the probability of occurrence of the event, that is A, probability that 2 can fall, is defined as, this symbol stands for definition. This symbol stands for definition, is defined as Na by n. Have you all understood what these two things come out with? We'll see certain axioms of probability. Probability of A will always be greater than 0. There is no negative probabilities at all. Either 0, and if there is an event that happens for sure, probability of S, probability of the sample space, then the probability of sample space, all the events to occur will be 1. So when you throw a dice, you are asking for probability of 7, it will be 0. You can never get 7. Right? So probability can be maximum 1 and minimum 0. So when you throw a dice, the probability of getting either 1 or 2 or 3 or 4 or 5 or 6 is certainly 1, right? You will be getting any of these values only. You will be getting any values between 1 to 6 only. So that probability, that is the probability of sample space that is mentioned here, right? This one, probability of an event that is not in the sample space will always be 0. Here, probability of event in the sample space, let us take that S to be a set of 1, 2, like this up to 6. In that case, the probability will naturally be 1 because it has to fall, any one number has to fall down between 1 to 6. So that if you are considering the event to be any of these numbers from 0 to 1, then it is naturally 100% it will occur. The next one is something very interesting. If A intersection B is equal to 0, that means you have two events A and B, and there is no way that A and B can have a common value, a same value, then probability of A and B to occur will be probability of A plus probability of B. Okay. You do not work too much with mathematical equations, don't worry about that. Try to understand the logic. Probability of A intersection B is 0 means A is completely different from B, and no way that an outcome of A will be the same as the outcome of B. In that case, probability of A and B to occur will be A plus B. Now listen carefully, I'm going to give you this with an example. The same example like what I've given you, the dice itself. I am throwing a dice. The probability of 2 occurring is A and the probability of 3 occurring is B. Clear? We are very sure that when you throw a dice, both 2 and 3 cannot occur. That means A intersection B is 0. Right? In that case, the probability of either 3 or 2 falling will be probability of 3 plus probability of 2. Understood, all of you? All of you are clear with this? I'm talking from the ground, from the very basics. School level mathematics, because I do not want any one of you not to understand any of these concepts. If you are unable to understand these concepts, it's very difficult for me to proceed. Is that clear? So a sample space is discrete if the number of its elements are finite or countable. You have number of points. For example, when I'm throwing a dice, what happens is that the outcomes are, or the sample space will be finite. You have the numbers. There are so many processes where you have infinite sample space, where you cannot predict continuous variables. You don't have any means to predict. Okay. So we have discrete and non-discrete sample spaces. Any subset of sample space is an event. For throwing a dice for one time, we have the outcomes 1, 2, 3, 4, 5, and 6. Am I right? So either this 2, 3 is a subset of the sample space. Is that clear? What is a subset of a sample space? What is a discrete sample space? And what is a non-discrete sample space? Events are the subset of sample space for which a probability can be defined. What is an event? Event is something that happens within the sample space. Let's see some examples of discrete samples. In throwing a die, various events such as, let us describe one event to be that outcome to be even. Another one, outcome is greater than 3. And the other one, outcome divides 3. These three things can be considered. These are all non-discrete samples because you have finite values. Every subset of sample space cannot be assigned a probability without sacrificing the basic intuitive properties of probability. some examples of discrete samples. We'll see non-discrete samples also as we go ahead. So we'll define something called as beta. What is beta? Let beta be an element of the sample space omega. In that case, if the subset E, which is an element of E, is an event, E, which is an element of a subset of the sample space, not the sample space, but is an element of the subset of the sample space, then EC, that denotes the complementary of E, that means all the things that E hasn't occurred. Suppose, let me take throwing the dice as an example. Sample space consists of all the values from 1 to 6. Let me take beta to be a subset where all the even numbers are falling. That means 2, 4 and 6. Okay. EC will be 1, 3 and 5. Okay, the complement of the event E. If EI, which is the element of beta for all I, then U of I is equal to 1 to infinity will be EI element of beta. Okay. So the probability that all events occur from 1 to infinity will be an element EI will be an element of beta. You will understand more about this in depth when we start studying about non-discrete sample spaces. Is that clear? Shall I proceed? So some more important points that you have to remember. Most of these things you have already studied, but still probability of an event will be between 0 and 1 for all elements within the sample space. The probability of sample space is 1. Disjoint events E1, E2 and E3, events where there is intersection is not possible or the intersection is null, and we have the probability of ui from 1 to infinity E of I will be equal to sum of all probabilities from I 1 to infinity P E of I. These three things, this probability, beta and sample space together is called as the probability space. So we will be seeing all the basic properties of probability measures. We'll be seeing about probability distribution function, cumulative distribution function, and so on. So we'll be studying the properties of probability measures. Okay, some more important properties. EC, complementary event, will be equal to 1 minus P of E. No. See, if this is E, this is the sample space, you have the thing with blue to be E, then EC will be all the areas outside this E. So this is EC. So P of EC will be equal to 1 minus P of E. Probability of a null set 0. Probability of E1 union E2, two events E1 and E2 will be P of E1 plus P of E2 minus P of E1 intersection E2. So you can imagine this very easily. You have two events E1 and E2, you have a sample space. You have E1 intersection E2, right? So probability of A and B occurring will be what? Probability of A, probability of B, and removing the intersection part. Very simple, right? Are you all able to understand? E1 union E2, E1 and E2 together. Okay, that what you're doing is you're adding this PA, PB. And both this intersection is already there, you're removing that. That's all. Is that clear for all of you? Okay. Then E1 complement E2. That means whether the probability of E1 occurring is less than or equal to probability of E2 occurring. Is that clear? Conditional probability. What is meant by conditional probability? Here, all of you. We have two events, E1 and E2. Imagine that we are throwing a dice 3 times. Okay, I'm going to explain these concepts to you. Listen to me very carefully so that you can understand these concepts very well. Only if you are able to understand these concepts, you will be able to do problems, and most of the questions that come for your exam will be problems. You have a die thrown 3 times. Let even be the probability that 2 has fallen, or even be the probability that 2 is the outcome. Okay. E2 be something like even numbers. Okay. You are throwing the die 3 times. Conditional probability is something that you have thrown the die first time and you got the outcome. Okay. That means that even has already occurred. First time you throw the dice and what happened? 2 has already fallen. E2 is the probability that an even number falls on throwing the die 3 times. Is that clear now? You are able to understand? You should imagine, only then you will be able to really get into the subject. Okay. Knowing that E2 has already occurred. So we know that 2 has already fallen. It reduces the sample space, right? It increases the chances of an even number falling again and again. Am I right? Yes or no? Sample space to the outcomes in E2. That means that we know that there are more chances. At least one chance is sure. You're throwing it 3 times. One time you got the even number for sure, right? So in that case, we define the conditional probability to be P E1 E2. This stands for conditional probability. Is defined as P E1 intersection E2 by P E of 2 if P E of 2 is not equal to 0. That imagine that in my example, whatever I'm trying to explain to you, I'm using that E2 to be even numbers. Okay. So probability of even numbers should never be 0. In that case, the conditional probability will be P E1 intersection E2 by P of E2. The second thing what is going to happen. Is that clear? Yes or no? In all other cases, we'll get, yeah, that is in case if P of E2 is 0, then the probability is naturally 0, right? Yes or no? Are you all able to understand what I am talking to you? Yes or no? So here the conditional probability explained with further examples. E1 is a probability of getting a number that is greater than 3. This is another example. So probability of getting more than 3 will be probability of 4 plus probability of 5 plus probability of 6. We get it as 3 by 6, that is 1 by 2. If E2 is the even that the outcome is an even number. So probability of E2 will be equal to 2 plus 4 plus 6, that is also 3 by 6, that is also 1 by 2. In conditional probability, what we are going to do is that we are going to presume what would happen to E2 if even has already occurred. Okay, that condition is called as conditional probability, a probability in which there are two events and the first event has already occurred. What is the probability of second event to occur? That is the question. Is that clear and legible to all of you? So we are calculating the conditional probability P of E1 intersection E2. Probability of 4 and probability of 6, that is there for both, no? Greater than 3 as well as an even number, divided by probability of E2. E2 is 3 by 6, 1 by 2. So the conditional probability of E2 occurring after even has already occurred will be 2 by 3. Now let us take a condition where we have a larger set of the sample space, that is E of I is equal to 1 is equal to, make a partition of the sample space and let us consider two conditions to be satisfied. Okay, U of I 1 to n, E of I will be the sample space as a whole. You have E of I to be the subsets of sample space divided between 1 to n, and let us consider two things, E, I and J, two events, intersection of which is a null set where I is not equal to J naturally. In that case, we are going to define what is total probability theorem. The next slide. A very important theorem. You can get a direct question on this, or sometimes you can get problems on this also. So this is total probability theorem. For the event A, total probability theorem is defined as P of A is equal to sigma P of A is equal to sigma I is equal to 1 to n. P of EI, P of A, conditional probability EI. This is called as total probability theorem. This is a very extremely important concept, as well as you have a lot of applications. You will be doing some problems based on total probability theorem also. So thank you all. Thank you for listening to me today. We'll meet again very shortly.